education is not learning of facts. It's making minds to think. Hello everyone. Welcome to Old School Electrical, where we simulate minds to think. Electricity powers our home, computers, vehicles, and almost all industries. We cannot even imagine a life without electricity. So everyone should know what electricity is. So if you want to understand electricity, you should know matter, atom, charge, atomic structure, forces acting on electron, electric potential, voltage and current. So in this lecture, we are going to discuss about all these things. First, let us start with matter. So what is a matter? Anything that has mass and occupies space is called matter. So this duster is matter because it has definite mass and it has volume, so it occupies space, so it is a matter. If you take the case of light, sound or heat, they don't have mass and volume, so they are not matter. So anything which is having mass and volume is called matter. Now let us see the composition of matter. So all matter is composed of small particles which are called molecules. And these molecules in turn is composed of tiny particles called atoms. So anything that has mass and occupies space is called matter, and all matter is composed of molecules, and molecules in turn is composed of atoms. Now come to the case of atom. In atom, there are two regions. The central core region is called nucleus, and the space outside the nucleus is called extranucleus. So the atom has two regions. The inner core region is called nucleus, and the space outside the nucleus is called extranucleus. Next, we will see the particles in an atom. So an atom has three types of particles. One is proton, the second one is electron, and the last one is called neutron. Proton, electron and neutron. The protons are positively charged particles. The electrons are negatively charged particles, and these neutrons don't have any charge. So atom has three types of particles: protons, electrons and neutrons. The protons are positively charged particles, electrons are negatively charged particles, and neutrons are neutral particle and it don't have any charge. The charge of proton and charge of electron are equal. The charge of proton is same as the charge of electron. So what is the difference? They are equal but opposite. Proton is positively charged, electrons are negatively charged. So they are equal but opposite in charge. Now let us see the atomic structure. We will discuss based on Bohr's atomic model. So in an atom, as we discussed, the inner core region is called nucleus. So inside the nucleus, we have two particles. The positively charged proton is inside the nucleus, and the neutral particles, neutron, is also inside the nucleus. The protons, positively charged protons, and neutral particles, neutrons, are inside this nucleus. And the outside space is called extranucleus, and in this space electrons revolves round the nucleus in specific orbits. These are orbits. The electrons will be there in orbits. These are electrons. This cross mark denote electron. They revolve around the nucleus in specific orbit. It looks like our solar system. In our solar system, sun is in the middle and the planets revolve around the sun in specific orbits. Here in an atom, nucleus is at the middle, which has protons and neutrons, and the negatively charged electrons revolves around the nucleus in specific orbits. And the orbit has orbit number. So all the orbits are numbered. The orbit which is nearer to the nucleus is the first orbit. So this is the first orbit. N denotes orbit number. So the orbit which is nearer to the nucleus is the first orbit, n equal to 1. Then the next orbit is n equal to 2. And the next one is n equal to 3. So n denotes orbit number. You got it? Now have you heard about atomic number? What is atomic number? Atomic number is the number of protons or number of electrons in an atom. Atomic number is the number of protons or the number of electrons in an atom. So what does it mean? In an atom, number of protons is equal to number of electrons. So in an atom, number of protons is equal to number of electrons. The protons and electrons are having equal charges, but they are of opposite sign. So what is the net charge in an atom, total charge in an atom? It will be 0, because number of protons is equal to number of electrons and charge of proton is equal to charge of electron, but proton is having positive charge, electron is having negative charge. They both will cancel each other, leaving the net charge of an atom as 0. So net charge of atom equal to 0. So we can say an atom is electrically neutral. Clear? Say consider an atom. For example, consider an atom which is having atomic number 20. We have to draw the atomic structure. So for drawing the atomic structure, we should know one concept. The maximum number of electrons that can be accommodated in an orbit is denoted as 2n square. So the maximum number of electrons in orbit is 2n square. That means 2 into n into n. So what is this? N denotes orbit number. The orbit which is nearer to the nucleus means n equal to 1. Next orbit means n is equal to 2, and so on. Now tell me, what is the maximum number of electrons that can be accommodated in the first orbit? N equal to 1. First orbit means n equal to 1. So what is the maximum number of electrons? Can you tell me? 2n square. So 2 into, now n is 1. 1 into 1. So 2. So the first orbit can accommodate only 2 electrons. What is the maximum number of electrons that can be accommodated in second orbit? Two into second orbit, so n into n. 2 into 2. N equal to 2. So 8. Can you tell me what is the maximum number of electrons that can be accommodated in third orbit? Two into n 3. So 3 into 3. So 9 2s are 18. We can calculate like that. So in order to draw the atomic structure, you should know the maximum number of electrons that can be accommodated in an orbit, which is equal to 2n square, where n is the orbit number. So accordingly, first orbit can accommodate maximum of 2 electrons, second orbit can accommodate 8, and third orbit can accommodate 18. So what is the question now? We have to draw the atomic structure for an atom whose atomic number is 20. So if an atom has atomic number 20, what does it mean? Number of proton is equal to 20. So what is the number of electron? Is also 20. Because in an atom, we will be having equal number of protons and electrons. Atomic number is number of protons or number of electrons. So now we can draw the atomic structure. So inside we will be having nucleus, and in nucleus we will be having 20 protons. Then first orbit, n equal to 1. Here we can accommodate only 2 electrons. Total number of electrons is 20. Then second orbit, here we can accommodate 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So how many electrons we have distributed now so far? First orbit 2, second orbit 8. So total 10. What is the balance electrons remaining? 10. Total is 20. We already distributed 10. Balance is 10. What is the maximum number of electron that can be accommodated in third orbit? 18. We can accommodate up to 18. So all the 10 electrons can be accommodated in the third orbit. N equal to 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the atomic structure of an atom whose atomic number is 20. Clear? And you should know one more thing, valence electron. What do you mean by valence electron? The electron in the outermost orbit is called valence electron. The electrons in the outermost orbit are called valence electrons. So in this atom, how many valence electrons are there? There are 10 valence electrons. The outermost orbit has 10 electrons. All these 10 electrons are called valence electrons. Is it clear? Next, we will move on to the forces acting on electron. Say this is nucleus. Say this is first orbit. Assume there are 2 electrons. And the nucleus is having protons and neutrons, and this denote electron. So what are the forces acting on electron? So actually 2 forces will act over the electrons which are revolving in the orbit. So two forces will act over the electrons which are revolving in the orbit. And the first force is the electrostatic force. First force is electrostatic force. In physics you might have studied there will be force of attraction between opposite charges. Opposite charges will attract each other, and like charges, same charge, similar charge will repel each other. Opposite charges will attract, like charges will repel. So inside nucleus we have proton. What is the charge of this proton? Positive charge. And outside the nucleus the electrons are revolving in orbits. What is the charge of electron? Negative. So this positively charged proton will exert an force of attraction over this negatively charged electrons. The positively charged protons attract the negatively charged electrons by an force. That attractive force is called electrostatic force. So what is the direction of the force? These electrons are attracted towards the nucleus. So the force is inward force. Because positive charges are in nucleus, this attracts the electrons. So this force, electrostatic force, is acting inwards towards the nucleus. Right? And the second force which is acting on electron is centrifugal force. The electrons are moving in orbit. As the electrons are moving in orbit, some force will tend to push the electron away from the atom. So there is another force. As the electrons are moving in the orbit, there is another force pushing the electron away from the nucleus. So there is an outward force. This outward force is the centrifugal force. This inward force is the electrostatic force of attraction. And the electrons will continue to revolve in the same orbit because of balance between this electrostatic force and centrifugal force. That is the reason the electrons will remain to move in the same orbit. Otherwise it will move towards the nucleus or it will move away from the nucleus. Okay. So the electrons which are revolving in the atom are bound to the nucleus by a force of attraction called electrostatic force of attraction. This electrostatic force of attraction can be also called as binding force. So once we say force, there will be an energy associated with the force. So the energy associated with the binding force is called binding energy. Are you clear? So what are the forces acting on electron? Two forces act on electron. What is the cause for the first force? Yes, unlike charges attract each other and like charges repel each other. So the positively charged protons attracts the negatively charged electrons by an force. So the electrons are attracted towards the nucleus. That electrostatic force of attraction binds the electrons with the nucleus. So that electrostatic force can be called binding force, and the energy associated with the binding force is called binding energy. So even though the positively charged protons attracts the electrons towards nucleus, the electrons are not moving towards nucleus. Why? Because there is one more force acting on the same electron. So as the electrons moves in the orbit, there is another force which is pushing away the electron from the nucleus. That force is called centrifugal force. Only because of balance between electrostatic force and centrifugal force, the electron will continue to remain in the orbit. Clear? Next we will discuss about charge. So as I told you earlier, electrons are positively charged, protons are negatively charged. Both are having same amount of charge, but they are opposite. But the charge possessed by one electron is very small. So it cannot be taken as unit of charge. So if you want to measure charge, it should have a definite quantity. So the charge possessed by one electron cannot be taken as an unit of charge. So the charge possessed by 6.25 into 10 power 18 number of electrons together is taken as the unit of charge. So the charge possessed by this much number of electrons, charge possessed by 6.25 into 10 power 18 number of electrons together is called unit of charge. And the unit of charge is Coulomb. It is denoted by capital C. Letter capital C denotes Coulomb, which is the unit for charge. Normally, charge will be denoted by the letter capital Q. Letter capital Q denotes charge. So, charge possessed by 6.25 into 10 power 18 number of electrons together is called 1 Coulomb. So, 1 Coulomb is the charge possessed by 6.25 into 10 power 18 number of electrons. So, if you want 2 coulombs, how much electrons together comprise 2 Coulomb charge? 1 Coulomb means 6.25 into 10 power 18. For 2 Coulomb means into 2. So, 12.5 into 10 power 18 number of electrons together means 2 Coulomb. You got it? So, unit for charge is Coulomb. So, what is the charge of 1 electron? Can you tell me? What is the charge of 1 electron? Charge possessed by 6.25 into 10 power 18 electrons is equal to 1 Coulomb. So, what is the charge of 1 electron? Means 1 divided by, this will go to denominator, 6.25 into 10 power 18. Can you calculate it and tell me? 1 divided by 1.65 into 10 power 18 is 1.602 into 10 power minus 19 Coulomb is the charge of 1 electron. But as I told earlier, electrons are negatively charged particle. So, when you write charge of 1 electron, we should add and minus sign. Charge of an electron is minus 1.602 into 10 power minus 19 Coulomb. Can you tell me the charge of proton now? Yes, plus 1.602 into 10 power minus 19 Coulomb. Are you clear about charge? Okay. So, next we are going to discuss about charging of a body. So, consider an metal piece. Say, let us denote it as A. Consider a metal piece denoted with the letter A. A may be copper, aluminum, iron or anything, some metals. What is the charge of this metal? What is the charge of this metal plate? Total charge of this metal plate. What is this metal plate? It is matter. This metal plate is actually matter. Why? It has mass and it has volume. It occupies space. So, it is matter. So, if it is matter, inside we will be having molecules. So, all matter is composed of molecules. So, inside the molecules we will be having atoms. And inside atoms we will be having protons electrons, neutrons. The protons are positively charged particles, electrons are negatively charged particles, neutrons are no charge. And number of positive charges and number of negative charges in an atom are equal. An atom has equal number of positive and negative charges. What is the charge of one positive charge? Charge of one positive charge plus 1.602 into 10 power minus 19 Coulomb. What is the charge of one electron? Minus 1.602 into 10 power minus 19 Coulomb. Say this metal has 20 protons and 20 electrons. So, if the metal has 20 electrons, what is the total charge of electrons? 20 into this much. If it has 20 protons, what is the total charge of protons? 20 into this much. And both signs are opposite. So, what is the net charge of this body? 0. 20 into 1.602 into 10 power minus 19 minus 20 into 1.602 into 10 power minus 19. So, it is 0. So, what we can conclude is, so if you take a metal plate, the charge is, net charge is 0. So, all matter are electrical in nature because protons and electrons are called electrical particles. So, all matter are having protons and electrons. So, all matter are electrical in nature because it has electrical particles, protons and electrons. But the net charge is equal to 0. So, all matter are electrically neutral. Clear? So, all matter are electrically neutral. Net charge is 0. Now, what is the question? How to charge this body? How to charge this metal plate? Why this metal plate is electrically neutral? Because inside the metal plate, if you have 200 electron, say for just a number, we are having 200 proton. If there are 200 electrons, there are 200 protons. That is the reason this body is electrically neutral. Its net charge becomes 0. Now, I want to charge this body to positive. I want to make this as positive charge. What should be done? If I remove 100 electrons out, what will happen? So, from this body, I am removing 100 electrons. What will happen now? Total number of electrons inside the body is now only 100 because 100 I have removed. What is the total number of protons? 200. Total number of protons is 200. Total number of electrons is only 100. 100 I have removed. So, what is the net charge now? Positive. So, if you remove electrons from a neutral body, it will become positively charged. Clear? Same metal. My requirement is to charge it to 1 Coulomb positive. I want to charge this metal to 1 Coulomb positive. Can you tell me what we have to do? As I told you earlier, if you want to charge it to positive, we have to remove electrons. But we want to charge it to 1 Coulomb positive. So, how much number of electrons has to be removed from here? 1 Coulomb means how many number of electrons? Charge possessed by 6.25 into 10 power 18 number of electrons together is called 1 Coulomb. So, if you want to charge it to 1 Coulomb, we have to remove 6.25 into 10 power 18 electrons. If you remove 6.25 into 10 power 18 electrons from this metal, it will attain 1 Coulomb positive charge. Clear? Next question, how to remove electrons? If I call electrons, electron come out, will it come? No. So, how to remove electrons? Because the electrons are already attached with the nucleus. They are bound with the nucleus by electrostatic force of attraction. So there is already a binding energy which binds the electrons towards the nucleus of each atom. So all these electrons are bound to the nucleus by electrostatic force of attraction. Associated energy we have studied as binding energy. So if I want to move the electrons out, I have to apply external energy to overcome the binding energy. So for removing, I have to apply energy to overcome binding energy, or to overcome the electrostatic force of attraction. So I have to apply external energy to overcome the binding energy to remove the electrons from the neutral particle. I am spending energy. Say for example, I am giving heat energy. That means I am giving thermal energy. I am giving thermal energy to this metal and I am removing 6.25 into 10 power 18 number of electrons. So spending energy means we are doing work. Okay. So I am doing work. I am spending energy means I am doing work. So I am doing work in removing the electrons from this neutral particle. So I am applying thermal energy to overcome the binding energy and removing these electrons. Is it clear? Have you studied energy conservation theorem? What is that? Energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed, but it can be converted from one form to another form. Energy can be converted from one form to another form, but we cannot destroy energy. We cannot create energy as well. So what I am doing to this metal plate, I am applying energy. I am doing work means I am applying energy. I am applying thermal energy for removing this much number of electrons, overcoming the binding energy. So I am applying energy inside this metal plate, and that energy cannot be destroyed. Where this energy will go? So whatever thermal energy I am applying to this metal will be stored inside the metal as potential energy. Okay, so inside the metal, now we are having stored potential energy. So whatever energy which I apply to overcome the binding energy for removing electron will be stored inside the metal as potential energy. Or in other words, the work done in charging the metal will be stored inside the charged particle as potential energy. So the stored potential energy in a charged particle is called electric potential. Clear? So for removing electrons, I am giving energy. That energy cannot be destroyed. So that energy is stored inside the metal plate as potential energy, and that potential energy which is stored inside the charged particle is called electric potential. Okay. Now let us discuss in detail about electric potential. Now can you define electric potential now? Energy spent in charging a body. The energy spent in charging a body is stored inside the charged body as potential energy. That potential energy is called electric potential. So energy spent in charging a body is electric potential. Or we can say energy spent means we are doing work. So I can say work done in charging a body. Work done in charging a body. I will explain with an example. Same metal plate. I am charging it to plus 5 Coulomb. So I am charging the metal to plus 5 Coulomb. What does it mean? I am removing electrons. How much number of electrons has to be removed now? How much number of electrons has to be removed to charge it to plus 5 coulombs? 5 into 6.25 into 10 power 18 number of electrons has to be removed to charge it to 5 coulomb. Say for example, the energy which I have applied or the energy which I have spent in removing this much number of electrons is 20 joules. So I have applied 20 joules for removing this much number of electrons to charge it to 5 coulomb. So the total charge in this body is 5 coulomb. What is the energy possessed by each coulomb of charge? So I have given 20 joules. That 20 joules will be stored inside the charge body. How much is the charge? 5 coulomb. So each coulomb of charge is having how much energy? That is the potential. So electric potential E equal to work done in charging a body. Charge denoted by Q. Work done divided by charge is electric potential. What is the total work done now? 20 joules. What is the charge? 5 coulomb. So what is the electric potential? 20 by 5. 4 with unit. Joules per coulomb. So what is the unit for electric potential? Joules per coulomb. There is another name for joules per coulomb, which is volts. The volts denoted by capital V. Is it clear? So each coulomb of charge inside the charge body is having an energy of 4 joules. So this body is having an electric potential of 4 joules per coulomb. Each coulomb of charge is having 4 joules of energy. That is the meaning. So electric potential is the work done in charging a body to 1 coulomb. So if the electric potential is 2 volt, what does it mean? If the electric potential is 2 volt, what does it mean? Each coulomb of charge inside the body is having 2 joules of energy. Each coulomb of charge is having 2 joules of energy. 2 joules per coulomb. You got the point? Now how will you define the unit for electric potential? How will you define the unit for electric potential? What is the unit? Volts. This is otherwise called joules per coulomb. Okay, how will you define it? Work done in charging a body to 1 coulomb. If 2 joules of work is done in charging a body to 1 coulomb, then the electric potential is 2 volt. You got it? Okay. Now we shall move on to conductor. So if you take metals or if you take any matter, it is of 2 types, conductor or insulator. So if you take metals like copper or aluminum, if you take metals like copper or aluminum, the electrons in the outermost orbit, valence electrons, are loosely bound to the nucleus. As I told earlier, at the center we have nucleus. Next we will be having the first orbit, next second orbit, and goes on like that. And What are valence electrons? The electrons in the outermost orbit are called valence electrons. The electrons in the outermost orbit are called valence electron. Can you comment about the force of attraction over the electrons in the first orbit, second orbit and last orbit? Which electron will have more force of attraction? The force of attraction is exerted by positive charges. Where positive charges are located? Inside the nucleus we are having positive charges, positively charged protons. This exact force of attraction. So electrons in the first orbit are nearer to nucleus. So the electrostatic force of attraction here will be more. The last orbit is far away from the nucleus. The distance is more. So electrostatic force of attraction here will be less. So normally the valence electrons will experience very less binding energy. The force of attraction over valence electron will be very less. But in materials like copper and aluminum, the valence electrons are loosely bound to the nucleus. What does it mean? The binding energy is very, very less, negligibly small. So what does it mean? The valence electron will easily come out of the atom. This electron, valence electron, will easily come out of the atom because its binding energy is very less. The force of attraction is negligibly small. So it comes out of the atom. So electrons which are coming out of the atoms are called as free electron. So what are free electrons? The electrons which are coming out of the atom are called free electrons. They are free to move from one atom to another atom. So the name free electron. Normally valence electrons will experience very less binding energy. So they will come out of the orbit as free electrons. Particularly in case of metals like copper, aluminum. If you take wood or plastic, say this is wood, this is or plastic, take the case of plastic. These valence electrons are tightly bound to the nucleus. Even though the valence electrons are far away from the nucleus, binding energy is more. That is the nature of the material. So it will experience more binding energy. So in materials like wood or plastic, the valence electrons are tightly bound to the nucleus. So will there be free electron? No, it will not have free electron. The valence electron won't come out of the orbit. It won't come out of the atom because its force of attraction is more. So materials which are having free electrons are called conductors, and materials which are not having free electrons are called insulators. Okay. So copper or aluminum are having free electrons. So they are conductors. Wood, rubber or plastic don't have valence electrons, so they are called insulators. Clear? And next we will move on to potential difference. You have to listen very carefully because this is very, very important. Say I am taking a metal A, maybe copper or anything, copper or aluminum, assume some metal, metal A. I am taking another metal B. It may be zinc or like that. Say this is copper, this is zinc. Let it be. A is copper, B is zinc. So two different materials. So in both cases, force of attraction over valence electron will be different. And now I want to charge A to plus 5 Coulomb. I want to charge B also to plus 5 Coulomb. Say A we have assumed copper, B we have assumed as zinc plate. This is a copper plate, this is an zinc plate. Both plates I have to charge it to 5 Coulomb. Say for example, just example, not the actual case. Say for example, in case of copper, the binding force is less. Here, the binding force is more. So, I have to charge it to 5 Coulomb. What should be done? If I wanted to charge it to 5 Coulomb, what should be done? I have to remove from here, I have to remove 6.25 into 10 power 18 into 5 number of electrons. I have to remove this much number of electrons to charge it to 5 Coulomb. What I should do here in the zinc plate to charge it to 5 Coulomb? Same thing. I have to remove, here also I have to remove 6.25 into 10 power 18 into 5 because I have to charge it to 5 Coulomb. 1 Coulomb means 6.25 into 10 power 18 electrons. So 5 Coulomb means into 5. So same number of electrons I have to remove in both materials, copper and zinc. And as I told earlier, in this material A, the binding energy is very less. Here, binding energy is more. So, since binding energy is more, I have to apply more energy externally to overcome the binding energy and take these electrons out. So, I am applying 20 joules of energy. Totally, I am giving 20 joules of thermal energy to remove this much number of electrons from this body. But come to the case of copper. Binding energy is very less. So, I need to apply only 10 joules. This numeric is example only. So, I am applying only 10 joules for overcoming this binding energy and removing this much number of electrons. So, what about the electric potential of body A and electric potential of body B? What is electric potential? What is electric potential? Charge, energy stored in each coulomb of charge. What will be the energy stored in each coulomb of charge? That will be the work done in charging the body. So, how much work is done here? 10 joules. Here 10 joules is the work done. Work done 10. Using 10 joules, I have charged it to 5 Coulomb. So, 2 joules per Coulomb, which is 2 volts. Joules per Coulomb is also called volts. 2 volt is the electric potential here. So, each Coulomb of charge in body A is having 2 joules of energy. That is the meaning. Each Coulomb of charge in body A is having 2 joules of energy. Or the electric potential here is 2 volt. Now come to the case of B. How much will be the electric potential? Electric potential equal to work done divided by charge. So what is the work done? 20. What is the charge? 5 Coulomb. So 20 by 5, 4 joules per Coulomb or 4 volts. So electric potential here is 4 volt. So body A or B, which one is having higher potential? Body B is having higher potential, 4 volt. Each Coulomb of charge here is having 4 joules of energy. Here each Coulomb of charge is having only 2 joules of energy. Here 4 joules of energy per Coulomb. Clear? So body B is at higher potential, body A is at lower potential. Now I am taking an aluminum wire. Using an aluminum wire, I am connecting both the metal plates A and B through an electric lamp. You know about our electric lamp, no? Bulb. So what will happen in bulb? Electrical energy converted to light energy in a bulb. So plate A and plate B, I am connecting together using an aluminum wire. Aluminum wire is a conductor. Using a conducting wire through and lamp. Now what is the potential difference in this? This is when it is connected, it becomes an electric circuit. So what is the potential difference in this circuit? What is the potential difference across this lamp? What is the potential difference across the lamp? I can denote it as PD. PD denotes potential difference. B is at higher potential, 4 volt. A is at lower potential, 2 volt. So difference in potential is 2 volt. So how will you define potential difference? Difference in potential between two charged bodies is potential difference. Difference in potential between two charged bodies is potential difference. This potential difference can be also called as voltage. What is the unit for voltage? Same, volts, because it is difference in potential. 4 volt minus 2 volt equal to 2 volt. So what is the voltage which is applied across the lamp? 2 volt. So what is voltage? Difference in potential between two charged particles. That is potential difference is voltage. Are you clear? Now, these two metal plates are connected using a conducting wire, say aluminum wire. Now what will happen? Here, the charges are having more energy. Each coulomb of charge is having 4 joules of energy. Here it is having only 2 joules. So assume an water tank. One water tank is at the top floor. Another water tank is at the ground floor. We are connecting both the tanks using a pipe, water pipe. What will happen? Water will naturally flow from higher tank to lower tank. Do you need any pump? No. There will be natural flow of water from higher potential to lower potential. Likewise, body B is at higher potential, body A is at lower potential. So charges will flow from higher potential to lower potential. So charges will flow from higher potential to lower potential. So when the charge starts to flow from here, how much will be its energy? 4 joules. Each coulomb is having 4 joules of energy. It starts to flow with 4 joules. When it comes to the lamp, it spends 2 joules, which is converted to light energy. And once it reaches here, it will have 2 joules. Clear? And this directed flow of charge is called electric current. So we are coming to the next thing, current. So what is current now? Directed flow of charges. The current is directed flow of charges. How will you denote current? Current is denoted using the letter I. How will you define current? Current is defined as the rate of flow of charge. Current is defined as rate of flow of charge. What does it mean? Charge divided by time. Rate of flow of charge means charge divided by time. So amount of charge passing through a section of the conductor in 1 second. Okay, that can be taken as unit of current. So what is current? Directed flow of charge. How will you define current? Current is defined as the rate of flow of charge. So charge divided by time means rate of flow of charge. So current denoted as I equal to Q divided by T. What is the unit for charge? Unit for charge is Coulomb. What is the unit for time? Seconds. So what is the unit for current? What is the unit for current? Coulomb per second. This Coulomb per second is also called as ampere, denoted using the letter capital A. So what is the unit of current? Coulombs per second, which is also called ampere, denoted using letter capital A. So how will you define the unit of current? If 1 coulomb of charge passes through the section of conductor, if 1 coulomb of charge passes through the section of conductor in 1 second, the current is 1 ampere, right? If 1 coulomb of charge passes through the section of conductor in 1 second, it is 1 ampere. If 2 coulomb of charge passes through the section of conductor in 1 second, what is the current? 2 ampere. 2 coulombs per second. So 2 ampere. So how will you define unit for current? The amount of charge passing through a section of conductor in 1 second. The amount of charge passing through a section of conductor in 1 second is the unit for current, and it is ampere. How will you mark direction of current? From higher potential to lower potential. Because current is directed flow of charges, it will flow from higher potential to lower potential. Clear? now I am going to bring in a variation here. And this flow of charges means we assume that the flow of charges is positive charges. Earlier days we believed that current is due to flow of positive charges. But after modern electron theory, we came to know that electrons are lighter particles. Its mass is very less compared to the mass of protons. Mass of electron is very much lesser when compared to mass of positive charges. So what does it mean? Which one will move faster? The lighter particles. So electrons are lighter particles when compared to positive charges. So electrons will move much faster when compared to protons. So before the positive charges start moving from here, the electrons reaches the other end. Before it start to move, the electrons reaches the other end because they are lighter and it moves fast. So after modern electron theory, we redefined current. Current is directed flow of electrons, not positive charges. Current is directed flow of electrons. So what will be the direction of electron? Opposite to direction of positive charges. Positive charges moves from higher potential to lower potential. So electron should move from lower potential to higher potential. This is the direction of electron. But still we use old convention. In any electric circuit, while marking current direction, we have to mark in the direction from higher potential to lower potential. We have to assume that current is due to flow of positive charges and we have to mark current accordingly. Even now we use only old convention. But we know that after modern electron theory, we know that electrons are lighter particles and electric current is due to the flow of electrons. These electrons will move from lower potential to higher potential. So I told an example. When we connect two tanks, one is at the top floor, other is at the ground floor, using a pipe, what will happen? Naturally water will flow from higher potential to lower potential. We need not want any pump or like that. But if I want to pump water from the tank which is at the ground floor to the tank which is at the top floor, what should be done? I need a pump. So I need extra energy. I have to give extra energy to pump the water from lower potential to higher potential. So I need a pumping system. I need to do work. Similarly, if I want to move electrons from lower potential to higher potential, I have to give extra energy. We will see the same example. So in body A, each coulomb of charge is having how much joules of energy? 2 joules of energy. Each coulomb of charge is having 2 joules of energy. What happens in B? If the electron has to be in B, each coulomb should have 4 joules. In body B, each coulomb of charge should have 4 joules. If the electron here has to reach body B, it requires extra 2 joules. Right? Here it has only 2 joules. If it has to reach body B, it needs an energy of 4 joules per coulomb. So I have to supply extra 2 joules per coulomb to transfer the electrons from lower to higher potential. So if I want to move electrons from lower to higher potential, I have to give extra energy. How much energy? I am giving 2 joules of energy per coulomb. What is that 2 joules per coulomb? It is equal to potential difference. Okay. So extra energy I have to give per coulomb is equal to the potential energy, 2 joules per coulomb. Okay. So how will you define potential difference in this case? So after modern electron theory, potential difference is redefined as the work done in moving 1 coulomb of electron from lower potential to higher potential. So potential difference is same as voltage. So how will you define voltage now? How will you define voltage now? Voltage is equal to potential difference. Actually, for matching the potential difference, I have to give extra energy to pump the electron from lower to higher potential. So voltage is the work done in moving 1 coulomb of electron from lower to higher potential. From higher to lower potential means we did not give extra energy. During this path it will release energy. But if I want to move electron from lower to higher potential, I have to give extra energy. So voltage can be defined as the work done in moving 1 coulomb of electron from lower to higher potential. So 2 volt means I have to give 2 joules of energy for moving 1 coulomb of electron from lower to higher potential, from body A to body B. But even though we know this, we still use only volt convention. We believe that electric current is due to flow of positive charges. Okay, so while marking current direction, we have to mark in the direction of higher potential to lower potential only. So what are the things which we have discussed now? We started with matter. Anything having mass and volume are called matter. And composition of matter, it is composed of molecules, and the molecule in turn is composed of atoms. This tiny atom has 2 regions, nucleus and extranucleus, and particles in an atom. 3 types of particles: protons, electrons, neutrons. Protons are positive particles, electrons negative particles, neutron neutral particles, and the protons and neutrons are located inside the nucleus. The electron revolve around the nucleus in specific orbits. Then we have seen the atomic structure based on Bohr's atomic model, wherein the important thing you should remember is maximum number of electrons that can be accommodated in an orbit is 2n square, where n denotes the orbit number. The orbit which is nearer to the nucleus is the first orbit, and we have to mark so on like that. So first orbit maximum can accommodate 2 electrons, second orbit 8, and third orbit 18, and so on. So what we have discussed next? Charge. What is the unit for charge? Coulomb. Charge possessed by 6.25 into 10 power 18 number of electrons together is called as 1 coulomb. So what is the charge of 1 electron? Minus 1.602 into 10 power minus 19 coulomb. What is the charge of 1 proton? Plus 1.602 into 10 power minus 19 coulomb. What next? We have discussed that all matter are electrical in nature because they are having electrical particles called protons and electrons, but they are electrically neutral. And how to charge this neutral particle? How to charge? We have to remove electrons. For removing electrons, we have to apply extra energy. And the extra energy which we are applying cannot be destroyed, and it will be stored inside the charged particle as stored energy. The energy stored in each coulomb of charge in a charged body is called as electric potential. So if you have 2 bodies having different electric potential are connected together using a conductor, then there will be flow of charges from higher potential to lower potential. That directed flow of charges is called as electric current. So current can be defined as the rate of flow of charge. I equal to charge divided by time. So its unit is coulombs per second. So difference in potential between these 2 charged bodies is called potential difference, and that potential difference is voltage. So potential difference can be also defined as the work done in moving 1 coulomb of charge from lower to higher potential, because even though we assume that electric current is due to flow of positive charges, now we know that electric current is due to flow of electrons because electrons are lighter particles. So how will you define voltage? Work done in moving 1 coulomb of charge from lower to higher potential. Unit is volts. And what is conductor and what is insulator? Materials which are having free electrons are conductors. Materials which are not having free electrons are insulators. Certain metals like aluminum and copper, the valence electrons are loosely bound to the nucleus, so they come out of the orbit as free electron. But in wood or rubber, the valence electrons are tightly bound to the nucleus and it won't come out of the atom as free electron, so they are insulators. They cannot conduct electricity. So to conduct electricity, there should be free electron. That's all we have discussed today, and in the next class, we will be discussing about battery and how it generates voltage. Thank you.